Welcome back to our FreeCAD Tutorial Series. In this video, we're diving into the Part Design Workbench, where we'll learn about the Part Design Workbench. Let's get started. So, what exactly is Part Design? In FreeCAD, the Part Design Workbench is specifically designed for creating complex 3D parts using parametric modeling techniques. This means every feature of your model is defined by dimensions and constraints, making it easy to modify or refine later. Think of part design as a structured way to build objects step by step. You start with a simple sketch, then add features like pad, pockets, holes, and fillets to create the final shape. It's ideal for designing mechanical components, housings, or anything that requires precision. To access the part design tools, first open FreeCAD and switch to the part design workbench. Every 3D model in part design starts with a sketch. Here's how to create one. Create a new body. Click the Create New Body button to start working on a solid model. Create a new sketch. Select a plane, typically the XY plane, and open the Sketcher workbench. Draw a basic shape. Let's draw a simple rectangle as the base of our 3D model. Apply constraints. Fully constrain your sketch to define its shape and size precisely. In FreeCAD, creating and modifying solid 3D bodies using parametric sketches to define shapes. Applying features like padding, pockets, and fillets. Features are what turn your sketches into 3D shapes. For example, the pad tool extrudes a sketch to give it depth. Now that you understand the basics of part design, let's take a closer look at some of the most important tools available in this workbench. Here's a quick rundown. 1. Pad. The pad tool is used to extrude a sketch into a 3D solid. Think of it as adding material based on your 2D drawing. Second, revolution. The revolution tool creates a 3D shape by rotating a sketch around an axis. It's great for making cylindrical or symmetrical parts like bottles or gears. 3. Additive Loft. Additive Loft connects multiple sketches to create smooth transitions between them. It's perfect for organic shapes or blending different cross-sections together. 4. Additive Pipe. Additive Pipe sweeps a profile along a path, allowing you to create complex tubing or rail-like structures. 5. Pocket. Pocket is similar to pad, but instead removes material from an existing solid. It's often used to create holes or cavities. 6th, hole. The hole tool simplifies the process of creating threaded or unthreaded holes in your part. You can specify the diameter, depth, and thread type easily. 7. Subtractive Loft. Subtractive Loft works similarly to Additive Loft, but removes material instead of adding it. Use it to carve out intricate shapes from your part. 8. Subtractive Pipe. Subtractive Pipe sweeps a profile along a path, removing material as it goes. It's useful for hollowing out parts or creating channels. 9. Boolean Operation. Boolean operations allow you to combine or subtract solids. You can perform union, add, difference, subtract, or intersection overlap between two or more objects. 10th, Fillet. The Fillet tool rounds off sharp edges, giving your part a smoother appearance. It's also useful for reducing stress concentrations in mechanical designs. 11. Chamfer. Chamfer creates angled edges, which can be helpful for aesthetics or machining purposes. 12. Thickness. The thickness tool adds or removes material uniformly around the surface, turning thin shells into solid objects or vice versa. 13. Linear pattern duplicates features in a straight line, saving time when you need repeated elements like holes or ribs. 14. Polar pattern arranges features in a circular pattern, which is ideal for symmetric designs like bolt circles or gear teeth. Gear. Why use pad design over other workbenches? You might be wondering why you'd choose part design over other workbenches like part or draft. Well, part design shines when you need to create complex, multi-feature parts with precision control. History tree. Every step of your design is recorded in the history tree, allowing you to go back and edit specific features. Feature-based workflow. Instead of manually shaping objects, you define each feature individually, which keeps your design organized. Parametric control. As I mentioned earlier, all dimensions and parameters remain editable throughout the process. This makes part design especially useful for engineering projects, product development, or anything requiring detailed accuracy. That's it for this introduction to the part design workbench. You've learned about part design and its features. In the next tutorial, we'll explore hands-on tutorials to create actual 3D models using these tools. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss a new tutorial. Have any questions? Drop them in the comments below. See you in the next video.